What's up, everybody? This is Tech G back with another video. And in this video, I'm going to be explaining to you exactly what a network switch is. So let's get into it. In the world of networking, devices must communicate efficiently to ensure smooth data transmission and connectivity. And one of the fundamental devices facilitating this communication is the network switch. Network switches are integral to both small-scale local area networks and expansive enterprise environments. And in this video, we're going to talk about the concept of network switches, explain what they are, how they work, their types, benefits, applications, and their role in modern networking. All right, so exactly what is a network switch? Well, this is a hardware device that connects devices within a local area network and uses packet switching to forward data to its destination. Unlike hubs, which simply broadcast data to all connected devices, switches intelligently forward data only to the specific device it is intended for, and this ensures efficient use of network resources and reduces unnecessary traffic. And here are some of the key characteristics of network switches. So the first part is packet switching. So switches, they use packet switching to manage and direct data packets based on MAC addresses of devices within the network. They have multiple ports. So network switches, they come with multiple ports, allowing various devices such as computers, printers, and servers to connect and communicate within the network. And they offer full duplex communication. So switches, they support full duplex communication, which enables simultaneous data transmission and reception between devices. So network switches, they operate at the data link layer or layer 2 of the OSI model, though some advanced switches also function at the network layer or layer 3. So here's a breakdown of how network switches actually work. So we have what is called MAC address learning. So when a device sends data to another device within the network, the switch reads the source MAC address of the incoming data packet and records it in a MAC address table, associating it with the corresponding port. Then we have what is called forwarding decisions. So the switch examines the destination MAC address in the data packet and looks it up in the MAC address table to determine the appropriate port to forward the packet to. Then we have packet forwarding. So the switch forwards the data packet only to the port connected to the device with the matching MAC address. If the destination MAC address is not found in the MAC address table, the switch broadcasts the packet to all ports except the source port. And then we have broadcast and multicast handling. So for broadcast and multicast traffic, switches, they replicate and send the packet to all connected devices, ensuring the data reaches all intended recipients. All right, so let's go ahead and talk about the different types of network switches. So network switches, they come in various types, each designed to meet different networking needs. So here's some common types of networking switches. The first is called an unmanaged switch. So unmanaged switches, they are simple plug and play devices with no configuration options. And they are typically used in small networks or home environments where advanced features are not required. Then you have what is called a managed switch, and they offer advanced features and configuration options, allowing network administrators to control, manage, and monitor network traffic. And they are suitable for large networks and enterprise environments. Then you have what is called a smart switch, and this is also known as a web managed switch. And this offers a middle ground between unmanaged and managed switches, and they provide basic management features through a web interface, making them ideal for small to medium sized networks. And then we have what is called a PoE switch, or a power over Ethernet switch, and this provides power to connected devices such as IP cameras, VoIP phones, and wireless access points through the Ethernet cables. And this eliminates the need for separate power supplies for these devices. Next, you have what is called a stackable switch, and these can be interconnected to function as a single logical unit, providing scalability and redundancy. And they are used in environments where network growth and high availability are essential. And then you have what is called a modular switch, and these allow for the addition of expansion modules, offering flexibility and scalability. And they are typically used in large enterprise networks with varying needs. And here are some examples of specific network switch types. So you have a layer 2 switch. This operates at the data link layer and uses MAC addresses to forward data within the same VLAN or sub network. And then you have what is called a layer 3 switch. And this combines layer 2 switching and layer 3 routing capabilities, allowing for inter-VLAN routing and enhanced network segmentation. All right, so moving on, let's talk about the benefits of network switches. So, network switches, they offer several advantages that make them a fundamental component of modern networking. And the first advantage is that of improved network performance. And it does this by forwarding data only to the intended recipient. So, switches, they do reduce unnecessary traffic and collisions, which enhances overall network performance. Then there's efficient bandwidth utilization. So, switches, they support full duplex communication, allowing simultaneous data transmission and reception, which maximizes bandwidth utilization. Then there's scalability. So network switches can easily accommodate additional devices, making it simple to scale the network as needed. You have enhanced security. So managed switches, they offer advanced security features such as VLANs, access control lists, and port security to protect network resources. Another benefit is simplified network management. So, managed switches, they provide tools for monitoring, configuring, and troubleshooting the network, simplifying network management tasks for administrators. And then there's power efficiency. So, PoE switches, they eliminate the need for separate power supplies for connected devices, reducing power consumption and simplifying installation. All right, next let's talk about some applications of network switches. So network switches, they are used in a variety of settings, from small home networks to large enterprise environments. And here are some common applications of network switches. So we have home and small office networks. So unmanaged switches, they are commonly used to connect devices in home and small office networks, providing basic connectivity and ease of use. You have enterprise networks. So managed switches, they are essential in enterprise networks, offering advanced features for network segmentation, security, and performance optimization. You can find them in data centers. So, high performance switches are used in data centers to connect servers, storage devices, and networking equipment, ensuring efficient data flow and high availability. They're on campus networks. So, network switches are used to connect various buildings and departments within the campus, providing reliable and scalable connectivity. You'll find them in industrial networks. So, ruggedized switches designed for industrial environments. They are used to connect devices in manufacturing plants, utility facilities, and transportation systems. And then there's telecommunications. So, network switches are used by telecommunication providers to connect network infrastructure and deliver services to customers. All right, next, let's talk about some of the key features of managed switches. So, managed switches, they offer a range of advanced features that enhance network management and security. And the first is that of VLAN support. So, VLANs, which stands for virtual local area networks, they allow network admins to segment the network into smaller, isolated subnetworks, which improves security and performance. There's quality of service, and this features enables the prioritization of critical network traffic, ensuring that important data such as VoIP and video are delivered with minimal delay and jitter. There's port mirroring, and this allows network admins to copy traffic from one port to another for monitoring and analysis purposes, aiding in troubleshooting and security monitoring. You have link aggregation, and this combines multiple physical links into a single logical link to increase bandwidth and provide redundancy. There's access control lists, and they enable admins to define rules that control the flow of traffic based on various criteria, such as IP addresses, MAC addresses, and protocols, enhancing network security. You have what is called the spanning tree protocol, and this prevents network loops by creating a tree structure of interconnected switches, ensuring a loop-free topology and enhancing network stability. And then you have network monitoring and management. So managed switches, they offer various monitoring and management tools such as SNMP or RMON, which stands for remote monitoring, and web-based interfaces to simplify network administration. All right, so moving on, let's talk about some future trends in network switching. So, the field of network switching is continuously evolving, driven by advancements in technology and the increasing demands of modern networks. So, here are some future trends that are taking place in network switching. The first is that of SDN integration. So, software defined networking, this is transforming network management by decoupling the control plane from the data plane. And network switches are increasingly being integrated into SDN environments to enable centralized control and programmability. Then you have higher speed and bandwidth. So as data consumption continues to grow, network switches are evolving to support higher speeds and greater bandwidth, with 100 gigabit per second and 400 gigabit per second switches becoming more common. You have IoT and edge computing. So, the proliferation of IoT devices and the rise of edge computing are driving the need for switches that can handle increased device density and low latency communication at the network edge. There's AI and machine learning. So, AI and machine learning are being integrated into network switches to enhance network management, automate troubleshooting, and optimize traffic flows. There's enhanced security features. So, with the increasing complexity of cyber threats, network switches are incorporating advanced security features to detect and mitigate attacks, such as embedded intrusion detection systems, enhanced encryption protocols, and automated response mechanisms. There's energy efficiency. So, as organizations strive to reduce their environmental footprint, energy efficient network switches that consume less power and support advanced power management features, they are becoming more prevalent. Another future trend is that of multi-gigabit Ethernet. This is increasing to accommodate higher data rates over existing cabling infrastructure, which will provide a cost-effective upgrade path for organizations. And then there's cloud integration. So network switches are being designed to seamlessly integrate with cloud services, enabling hybrid cloud environments and facilitating centralized network management through cloud-based platforms. All right, so to wrap all this wonderful information up, network switches, they are a cornerstone in modern networking, enabling efficient and reliable communication between devices. They come in various types, each suited to different networking needs, from simple unmanaged switches for home networks to advanced managed switches for enterprise environments. Understanding how network switches work, their benefits, and their applications is essential for anyone involved in network design, management, or security. And the continuous evolution of network switches, driven by advancements in technology and changing network requirements. This ensures that they remain a vital component of network infrastructure. And as we move towards more dynamic and complex network environments, the role of network switches will only become more critical. So whether you are setting up a small office network or managing a large-scale enterprise infrastructure, selecting the right network switch and leveraging its capabilities, this can significantly enhance network performance, security, and scalability. And by staying informed about the latest trends and best practices in network switching, you can ensure that your network is well equipped to meet the demands of today and the future.